We've got a calculating quantities calculation here. A bit of a twist though, because it's giving us two equations and asking us basically is reduction A correct or reduction B correct? Let's read the question just so you know what we're doing. Two copper ores, copper oxide Cu2O, that one there, and CuO, copper oxide, that one there, are shown here. Copper can be produced by reducing the ores with excess carbon. Carbon's more reactive than the copper, so it displaces. The copper takes the oxygen from the copper. The equations for the two reductions are below. So we've got reduction A and reduction B. It says 429 kilograms of one of these ores. So let's write 429. I like to write the mass on top of the reactants. 421 of one of these ores produces 381 kilograms of copper. So let's write 381 over there. Okay. What we have to do is carry out a calculation to decide whether reduction A or B is taking place. Okay, so this is our raw material. So this is a calculating quantities. All calculating quantities have three stages. Moles, stoichiometry, and moles again. Now the moles equation for this calculating quantities is moles equals mass over atomic mass. Moles equals mass over atomic mass. Actually, I'm going to say formula mass there because we're starting with copper oxide. We're just using the abbreviation MR for formula mass. So let's calculate the formula mass in reduction A of copper oxide. So that's going to be copper plus oxygen. I've got two coppers in there, Cu2 and O. One copper is 63.5. So that's going to be 63.5 plus 63.5, and the oxygen is 16 plus 16. I'm thinking that looks like 143, but let's stick in the calculator just to see. So 63.5 plus 63.5 plus 16 equals 143. Happy with that. Okay, 143. So that's our formula mass. Our mass was up here, 429. 429, so 429 divided by 143 is as follows. 429 divided by 143 equals 3. Okay, so that's the moles in reduction A, but of course we've got two reductions going over here, so we need to do it, so that's for A, so we need to do it for B as well to work out which one's correct. Exactly the same. Moles equals mass over MR. Our mass is 429. This time our formula in B is CuO, so that's just one copper and one oxygen. So that looks like 79.5 to my mind, but let's just double check it. 63.5 is the copper, plus 16, that's the oxygen there. Add those two together and we've got 79.5. So this time it's going to be 429 because that was the mass that we put into it, divided by 79.5. Let's stick that in a calculator. 429 divided by 79.5. 5.396. Okay, stoichiometry. Okay, stoichiometry is the big numbers in this equation. Basically, we can cross out everything that we haven't written a number on top of at the top here. So in the first equation, 2 copper oxides makes 4 coppers. Let's write that out here. So let's put a line down there. So 2 copper oxides make 4 coppers. And in the second one, we've got 2 copper oxides make 2 coppers. So 2 copper oxides make 2 coppers. Right, so what we're looking at here is these numbers. 2 there, 4 there. And we're going from that number there to that number there. So how do we make 2 into 4? Answer, we have to multiply by 2. Well, we don't start with 2 moles. We calculated here, we start with 3 moles. Let's write our 3 there. Whatever we had to do to that number to turn to that number, doubling it, we have to do to the 3, so let's double it, times 2, so that's going to be 6 moles of copper are made. In this example here, 2 is the same as 2, so to go from there to there, it is the same. We didn't start with 2 moles, we started with 5.396. 5.396 moles. So in this example here, 5.396 moles of copper are going to be made. Okay, final stage, moles equation again. This is moles equals mass over mR, but what we need to do, we need to find the mass, so we need to rearrange that to make mass the subject. Mass is moles times AR. Mass is moles times atomic mass. I'm using the abbreviation AR for atomic mass. Right, moles in this one was 6. Copper atomic mass 63.5. Moles in this one 5.396. And the atomic mass of copper 63.5. Now one of those is going to equal 381. I'll let you finish that off, and then that will be the right answer. If A is 381, then reduction A is taking place. If this one is 381, then reduction B is taking place. All these questions on ayleshamhighchemistry.com.